I mean, like we are currently having an Atcoder contest. So let's just get the window ready for the contest. I guess this is the window. So there are still 3 minutes left out. So let's wait for the contest to start. Atcoder 419. Well, let's create the folder ABC 419. Prepare for the first problem. We just have the broader template. Just close the terminal. Let's disable the copilot. It just is quite annoying. Yeah. So GitHub Copilot disable and restart extensions. So this should be fine because in contest cheating is not allowed. And I don't need to cheat actually. I can solve a lot of problems by myself. And the Copilot just distracts me from what I am thinking. So let's wait for the contest to start now. Alright, so let's wait for 1 minute. I hope the problems are like a bit easy. I should be able to solve 5 problems if I am really kind of focused. Yeah, I should be able to solve 5 problems, I guess. But I cannot be certain about that thing. As I said, I would say that the Atcoder beginner contest is a really good contest. Like for learning and obviously for the development of the brain, it just is really best. It's better than Code Courses, Lead Code, and all the platforms, I guess, considering the problem statements and everything, constraints too. So let's rate, yeah. So go to the task list page. Let's just get the A, B, C, D, E. Okay, he memorized headquarters words to English words. Okay, red, green, blue to respectively SS. Okay, of 3X and change. Okay, okay, so you have to. Okay, so we have to take the string str. If it was equals to the red, okay, red corresponded to FF. Red, green, no? It should be green, blue, red. It's gonna be S caps, I guess. Or we'll print the endl and okay, and we have the M right for green ML. STR if it's equals to the green, C out, M, and then and C out unknown, and then so let's check out the spelling. This should work out. Run with test cases. Obviously, it's just gonna comment the TT line and just build it. Okay, okay, okay. So submit it. Oh, we get submission back. Okay, let's wait for the acceptance. This is the really easy problem. There is nothing as far as the difficulty is considered. Wait, let's wait. Okay, let's move to the problem. Okay, Q queries. Process the queries in order and output the output to each type two queries. Okay, okay. So minimum. Oh, we can maintain a minimum. Go to problem B. B dot cpp. Maintain a broiler template, broiler, and number of queries. And obviously the test cases should be commented out. No test, only single test case. If the type, so first of all, we take the type, cin type. So if the type was one, then what we do? We can take int max. So we can define with the int max, int val, cin val. We just take the input of val, mini equal to mini, and then val else cout mini. Okay. So we just are just implementing that thing. So I hope this works. 6 1. So let's look at the ranges for once. Okay, so we can submit it now. Agreed with 10 to the power 9 rows and 10 to the power 9 columns. I comma G, okay. I throw in jet count from the left, okay. There are n people on the grid. Initially, the ith person is at the Ri comma Ci. Time starts. I don't know what the fuck it is. Oh, why the server is so slow? I don't know. But there is a grid, okay. N people in the grid, and they are represented by the coordinates Ri comma Ci. Time starts at 0, and each person can move at times 1, 2, 3, 4. Okay. One of the squares is moved to an 8 adjacent square. Okay. Leave the grid. Move to one of the. Okay, we can move I minus 1, J minus 1, I minus 1. So the positions are given. Like, if you understand what is happening here, you can understand that these are the squares that you can move from that point at each minute, right? Okay. Okay, the minimum possible time at which everyone is in the same square. Fine. So there are n people. Imagine the n people, and they must be in the same square, right? So you can move to what? 8 points. Let's understand what are the points we can move. Sorry, I hope I'm still audible. It was just a bit distraction. We can go to the OneNote to visualize what is happening here. So basically, what is happening here is, so what is happening here is we are given a grid. Okay, so we are given a grid. So what are the points that we can move from the grid? So obviously we are able to move here, 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 here. Every point, I guess. So it's 6, 7, 8 points. We can move to every adjacent point. That is what it's been said, right? So minimum time. So you can move to every point. So one point to another point, you can move it along the diagonal. So number of points in the diagonal is the solution, right? That is, suppose you have a rectangle, you have to move from this point to somewhat a point like this. Somewhat you have to move from this square to this square. So you kind of get there and get here and move to the diagonals. So how will we solve this problem? This looks a bit standard, but what should be the solution? Solution is just a bit tricky. Let's figure out. Uh, let's figure it out. So obviously they will meet out at some point within the grid. Or since the grid is really large, we don't know where we have to meet, right? So let's understand the, I guess, 10 to the 1 and 10 to the 9, okay. And let's look at the input constraints. Okay, they are huge. That was 2 comma 3. So what is the, suppose we want to reach from x1 comma y1 needs to reach to x2 comma y2. So what is the distance you have to kind of travel? So first of all, the minimum, you need to consider the minimum one also. So the minimum, so minimum of what you can take is absolute difference between x and x with y, absolute difference between the y's, and that will be the time the to cross the square, or you can take the maximum. You have to take the minimum for the square, right? Hmm. Plus maximum minus minimum. So it is going to be somewhat like this: max, this is the max, minus min, plus min. So it's going to basically take the max steps. Max steps. So maximum absolute difference. Maximum absolute difference. So it's a C problem. You should not overthink here. Overthinking is really bad here. You should not feel stuck in Atcoder. Once you feel stuck, you should move on, or you should just wait for 2 minutes. So if you just look at this, what is the point that you should think that they will meet at? Mhm. So we have to kind of think in the way of maximum absolute difference. Hmm. Okay, we buy and research. We basically do is what we do is buy and research. We can buy and research for the time. Since it's a minimum time, what we can do is basically buy and research. And what are the places that we can visit? So let's understand what are the modes you can visit. So initially, this is you can visit everything over here, and everything over here you can visit everything over here, and like, you can visit everything over here. So like we need to take the intersection there. Fine, I got the solution. So basically, what's happening is first step is what binary search for the solution, binary search, and then we can visit everything, everything over here, everything over here, everything over here. So what will be the range? X comma y. You can visit the x is going from x minus of that t and x plus t is going up from here. Okay, fine. The range of x you can cover, and this is what is the range of y you can cover, and the range of x and the range of y. This is what you can cover. So they should have some same intersection, right? Yeah. X coordinate can go to in this range. So for whenever we want to take an intersection, we'll take intersection of the x coordinate from where the x is going on and from where the y is going on. So all the points in this range will be coming out, right? Okay. Uh, there will be lot of points. So we have to think a bit cleverly. Okay, first I will write out my research, and then when we got this and this and this, what is the points? What are the points that we can cover out? X can go from x1. We have the x range and you have the y range for the corresponding x. Yeah, we keep on taking the intersection. Suppose 1 comma 2, 2 comma 7. We take the intersection, it's 2 comma 4. 2 comma 2 comma 4. So yeah, this is what you need to do. You need to take the intersection of the x as well as the y. I hope you are getting it. Suppose you're going from 1 comma 2 to 3 comma 10 and 1 comma 2 to 5 comma 10. Then you can go to the y can go to this range only for this thing. So I hope this should work. Okay, so where is that file? Code chef ABC, right? C dot cpp wait. Broiler template. Take the n. Okay. Vector pair. uh, Okay. While now binary search, while low is less than high and mid, low plus high, right should be high too. Okay, search. High should be equal to the 1e9. I can go with int max, or I can just go with int max. Fine. Okay, I can go with 1e9 because int max seems out to be too wide. And we have low plus mid upon 2 upon 1, and we just check for the mid. Okay, if ck mid, and we can define an answer variable. Answer int answer equal 1e9, answer equals to mid, and we look for a smaller answer. Else, in the other condition, else we look for a greater answer because we did not get the answer. And we write the set auto ck. A check function would take and mid into mid and will return a boolean, writing a lambda, and where we can maintain a pair. We can maintain ll x range xl, and xl equals to, suppose we can initialize it to 1 2, xl equal 1, xh equal 1e9, and x and y low equal 1, yh equal 1e9 again. And what we do is point I equals less than n. If we take the intersection, in curve would be what? Current x range. So the current x should move from really long. Current would go from points I dot first. We can give it a capital XL. We can use preferably define long kind of avoid some overflows, which is just headache others. So we just have the long dot first minus of what mid, and XH would be okay. Let's use this auto X comma Y would be points I, and then what we can do, we can return a group, and X comma Y is just this. Oh, and you have a couple of ranges now. U would be the maximum of them. Would be max of X minus of what? Mid. XH would be a min of XH comma X plus mid. Fine. And YL would be, we can kind of translate it, copy paste it. And here we can use the multiple Y. And for that, again, you can use a YL. And again, you can use a Y. I hope that's clear here. If XH is greater than XL, return false. If YH is greater than YL, if YH is we just what was, yeah, we return a false. Immediately we return a false. So yeah, and we see out the answer. 3, yeah, correct solution. Let's check with this. 44 should be the solution. Yeah, this should be correct. Okay, I got a wrong answer on problem B. We maintain a priority queue. Oh, one minute. PQ dot push PQ dot top. Okay, we got solved three problems. Like, okay, this, let's go for the what is this? We're gonna string to lowercase English strings SNT and M pairs of integers LR. Okay, third and fifth. Swap Li through Rith characters of Sn. I do not understand the operation. So let's go with this problem. Wait. D should be easy. I do not Li in pairs like two strings SNT and M pairs. Swap. Perform the operation is not. Swap the Li through Rith characters of S. Okay. I don't understand the operations first of all. Li through character. You need to perform operations as that. Okay, we need to increase by one. Mhm. We can write an n square m, any term solution. Oh, what else? I did not understand the problem basically I'm speaking. Let's understand the problem. First of all, I have to understand the problem, right? Uh, I did understand the problem now. Like, I don't know what's happening, but let's see. So we have to swap the substrings from L to R, right? What can we apply? It is not feasible to swap the substrings, right? Obviously, lot of operations. Um, Suppose we have swapped number of times in each character is, yeah. So got the solution. Number of times each character is swapped. That is what we have to keep a count on. And we can use a difference array technique. Yeah. Yep, we can use a difference array technique. It was 419. We will apply difference array technique. And Q. What are the inputs? String str, string s and t. And we apply queries while q minus. Yeah, we'll apply l minus minus and diff l plus plus comma diff of r minus minus and sum equals 0. And we'll have diff I if sum modulo swap si comma ti c out s. Okay, so we applied difference array technique to leverage the solution, obviously commenting on the test cases. LPLL, correct? Okay, copy. Okay, we got the accepted. So this was the solution. Let's go to the fifth problem of the Atcoder. Add integers. The sum should be multiple. Okay. So minimum possible number of operations before achieving the goal. Okay. So minimum number of operations. Obviously, we need to make the multiple of m, and every value is from between. And it is less than m. So we can apply some k number of operations. Suppose we'll buy research for the operations. Minimum number of operations to achieve before achieving the goal. Okay. What the length we are considering of the subarray? Okay, so how can apply what is the sum? Modulo and max will apply k operations. Minimum number of operations. Okay, five. What is the time complexity required? 500 into 500 into 500, which is 10 to the. This will get accepted. So dp of, add a new page. So what you can apply is dp of I comma j comma k. What is I comma j? Can we make number of operations required to make the sum between I to j as modulo, that is k. Everything is satisfied. And the previous j elements is this. Number of operations that we have to apply. So that number of operations that we have to apply, that previous j, sum of the previous j elements is k. That is what we are thinking. And every condition is satisfied. So let's apply the dynamic programming logic, and we can use space optimization to kind of do that prevent curl technique. Value 9 and problem E. Oh yes, okay, problem E. E dot broiler subarray, right? Mm-hmm. N, M, and N, and array. And M, C, N, M, okay, vector of in. Okay, 10 to the power 9 will be really huge, right? Okay. Vector of mint A of N, take the input, pass the pointer, and then apply DP. Vector of int will 2D vector. Int will apply a prev. Prev would have what? Considering the previous L elements, and the modulo. So modulo of the sum is M, and it will be int max. And we can use a VLL to kind of optimize this. VLL L plus 1 and int max and semicolon. I is an M, I plus plus, and we have to make a curve. Yes, we know that. Car zero. We only know that car zero is what? Oh, prem sorry, prem zero is a zero. What is the length and what is the module you can get? And its car and it will be mini. Currently having. This is the base case. Obviously, we don't take a zero elements. Suppose if the L was one, then we directly we actually want the some of the zero elements out. Right. How can we transition? Sorry. How can we transition? As a module, okay. We apply operation and we don't apply operation. We are going to apply operations in. Mm-hmm. And M, okay. Uh, Sum of M11's module. That is this. We are applying operations this much. A teacher meant we can only apply operations of it. Yes. Previous key elements. If I apply procedure, the K minus one had a sum of x. We should not always never feel stuck in it. Let's look at the standing. 3000. This is really bad. Number of teams that contain. Oh, well, very difficult when I got solved. Okay, NQ. I for one loop and second two loops. What are the states? Previous K minus one elements will only matter. And minus K minus that element. Yeah. N minus L plus one element. Okay, let's think greedy love. Okay, what is the minimum? If I increase the eighth value, okay. If I apply what? M operations on I. X operations. Okay. This is modulo 0. This is the new reminder. This is 0, right? Mhm. Okay. ಮಾಡ್ಲಂತ್ರನಾ taking the operations methods. Okay. Yes, I will test yours. What other we have to add? Okay. Greedily. Yes, I've solved five problems so far. And let's go to the sixth problem. So, Boolean and string. Well, let's do this first one, standings. This is still really bad. Like the last problem, I thought a lot, and then it came to a solution that I applied dynamic programming ideas at last. Okay, what is the number of strings of having length and having all of them as a substrings? And we have 26 to the power 10, which is uh 26 to the power. I don't know. I don't have that much time to solve it. Okay, so bitwise, 26 bits. What I can do? Mm, number of substrings having everything else. Okay. You have got everything at that point. We have so far covered out these things. In 4 minutes, I cannot solve. So let's end it here because I cannot solve it in 4 minutes, as I know that. So let's end it here. I have solved five problems today. It was a really good contest.